Hi there, in this lesson we're going to look at the National 5 application Specimen 1 trigonometry questions, which are basically questions 1 to 3. Okay, let's look at the first one. So Jamie wishes to grow strawberries in a triangular plot of ground. The diagram gives the dimensions of the plot. Calculate the area of the plot to the nearest square metre. Now the first thing you need to realise is this is an area of a triangle question. So you go to the formula sheet and you're presented with these three formulas. So you look down to see the area of a triangle 1. That's the only one that will get the area. These will all get side lengths or angles. So that's the formula you want to write down. Half AB sine C. Also, we'll put it away. The other thing is they've not got letters on the triangle in their diagram. I've just put them in. C is where the angle's at. So I've put C there. Small c diagonally opposite. Small b diagonally opposite capital B. And capital A diagonally opposite small a. Now, it doesn't really matter which way around A and B go, to be honest here, as long as you've got C as the angle. Okay, so what you want to do here is 1 divided by 2 times A, which is 14, times 26, or the other way around, and times the sine of 48. As long as you take that correctly into your calculator, make sure you're in degrees mode in your calculator, and you should get 135.25 metres squared. It's metres squared because it's the area. Right, let's look at question 2. Now I'll bring the formula sheet down with us so we can have a look at that as well. Right, so question 2, the diagram shows how a golf ball was hit from T to position A. So somebody's hit a golf ball and it's went like this to there. The hole is actually on that direction. There's the T to the hole. So if they were trying to get a hole in one, they'd hit it in that direction. Now your job is basically to work out how far, what's the shortest distance between the golf ball, which is here, and the hole here. So it's that distance there. Okay, now they've got capital letters for their angles, if you like, which is absolutely fine. You would fill in the shorter sides. It's always good to draw these diagrams out. Or not the shorter sides, but the side lengths, so the small letters. So it's small t diagonally opposite capital T, small h diagonally opposite capital H, and small a diagonally opposite capital A. Now this is a cosine rule question. The reason I know it's a cosine rule question is because I've got the two sides and the angle in between, and that's a cosine rule question. That allows you to work out the kind of last side that's there, that one. Now, when you're looking at the cosine rule in the formula sheet, there's two cosine rules. You've got this here or this one. This one's for working out angles, which we don't do in this unit assessment. So it's that first one you're looking for. Now, it starts with a squared equals, but we're trying to work out t, so we're going to start t squared equals. Now, what you should also notice in the formula sheet is you've got an a at the start and a capital A at the end. Then you've got BC here and BC there. So we're going to do the same thing, but with our letters. So instead of using these kind of letters here, B and C, I'm going to use A and H. So you'll see it here, a squared plus h squared, and then 2 times AH, or minus 2 times AH, and then cos of capital T. So it looks pretty much the same as the formula here. I've got a small case A and a capital A at the end, small t, capital T at the end. I've got my other two letters in the middle, BC, BC, AH, AH. So it should look exactly the same, but with your letters. After you've done that, it's just a case of filling the information in. So A is 285, so we're squaring that, plus 210 squared for H. Now, because we're taking away a lot of things, I tend to put that in a bracket. 2 times A, 285, times 210, times the cos of this angle here, which is 30. Again, type all of that in. See all this bit here, exactly like that, into your calculator, and it should pop out with an answer like this, 21,661.75. Now that gives us t squared. Think back to Pythagoras, when you had something squared, you had to undo that, square root your answer, just leave that in your calculator, square root it, and you'll get an answer of 147.2 yards, because we're dealing with yards up here. Okay, last question here on the trigonometry questions. So question 3. Ocean buoys in the Pacific are positioned at J, M and C as shown below. Okay, so we've got J, M and C. I've put my small letters in, so M's diagonally opposite capital M, small c diagonally opposite capital C, and small j diagonally opposite capital J. Now this is the last question here. We've already used the cosine rule. We've already used the area of a triangle formula. This is the last one we're going to use, which is the top one, the sine rule. Now the reason it's a sine rule question is because what we're trying to do is get this angle here, and I'll talk about that in a second, but that allows us, we've got angles opposite sides and sides opposite the angle. We're trying to find this crisscross kind of shape going on, and that's usually a sine rule question. Right, now let's have a look at the actual question. What is it asking us to do? It's saying calculate the bearing of Curly from Mitchell. So it's given us this diagram, some other information, but the bearing is basically of Curly from Mitchell. So you're standing here and the bearing is taken from the north line round in a clockwise direction. So we're looking for that angle there basically. But we can't really get that. It's out with the triangle, but what we can do is work out this angle in the triangle, and that should allow us to get this kind of bearing. Remember, bearing's always north from the north line in a clockwise direction. Right, so I'm going to set up this kind of the sine rule. Now, because I'm working at an angle, we flip the sine rule over and we have angles on top. So sine A over A, sine B over B, and sine C over C. And we have to recognise, I talked about it before, the pairs of angles we're going to use. So we're going to use M's and we're going to use J's. There's no reason to use C's because there's no angle at C and there's no side length C. So we're going to use M's and J's, taking care to put the angles in the top instead of this way around. And then again, it's a case of kind of filling in the information. I'll get rid of this now. I don't really need that there. If we can fill in the information from the diagram and work this through, we should be okay. So remember, I'm trying to work out this angle here, if you like, first. Right, so sine M over M. I don't know what M is, so I'm going to leave it as sine M. Small m is 124. Sine of j, j is 115, so that'll be the sine of 115, and small j is 342. Okay, well let's work out what sine M is, and to do that we need to multiply this side by 124. So we're going to do that, times by 124. You can think of it as doing the same to both sides. Times this by 124 and they would cancel, and times the other side. Now type all that into your calculator, sorry. Just type 100, sine 115, divide by 342 times 124. Make sure you get brackets around your 115 in your calculator, and that should pop out with a big long answer like that. Now that's not your angle, of course it's not 0.3 degrees there. So what you have to do is inverse sine to get your actual angle. So inverse sine that, keep it in your calculator, and it'll pop out with 19.2 degrees. Now again, that is not your answer, that's this green bit, but the question said what's the bearing, so that's that yellow bit. Now this is a straight line down here, and if you take the 19.2 away from 180, you're going to get your bearing. So there you are, 160.8.